Hello, welcome to Unit 8, Lesson 3 with Professor Blackman. In this lesson, we're going to be talking about polynomial division. We're going to start out with long division, then we're going to use synthetic division. We'll be looking at the remainder theorem and the factor theorem, all with synthetic division. Let's go ahead and get started. All right, with long division, what we're going to do is we're going to take what we're dividing by, put it over here on the side, and the big polynomial we're going to write underneath. Now, before we get started on this problem, I want to do a simple long division just as a quick refresher. So let's say you have 147 divided by 12. So you would write that as 12 with 147 here. You figure out how many times 12 goes into 14, which is 1. You put the 12 here, then you subtract. You bring down the number, bring down the next number. So 14 minus 12 gives you 2. You bring that 7 down. And then you figure out how many times 12 will go into 27. It's 2 times. And so then that would 12 times 2 gives you 24. Subtract that, you get 3. Now you either can write this as a remainder 3, or sometimes we'll write it as 3 over 12. Now again, that can simplify, but with polynomials, this term up here is never going to simplify. All right, so for our problem, we're going to do the same thing. Well, how many times can x go into x to the fourth? Well, it's a little bit different because we need to multiply something to turn x into x to the fourth. Well, that's going to be x to the third. Now, when I'm starting out with a problem like this, sometimes I like to show my work on the side. So I'll take the x to the third times the x plus 1, multiply that out, and that gives me x to the fourth plus x to the third. And so that's what I'm going to write over here. Now, just like before, in our other long division example, we subtract this. So you need to subtract every term. So this positive is now negative. This positive is now negative. Because this is positive, positive, these will either always be negative, negative, or positive, positive. First terms cancel out, and then we get negative 6x to the third minus x to the third gives you minus 7x to the third. Bring down the next term, which is our x squared. Now, same thing. What do I need to multiply by x to turn this into this? We're going to use negative 7x squared. Show the work over here. Distribute, and you get negative 7x cubed minus 7x squared. And so write that down, negative 7x cubed minus 7x squared, and then subtract that. So this negative becomes positive because when you subtract a negative, you get positive. First terms cancel out. X squared plus 7x squared gives you 8x squared. Bring down the next term, which is 24x. And what multiplies by x to turn into 8x squared? That would be 8x. Do the work over here if you want. Multiply that out. You get 8x squared plus 8x. Subtract that. Subtract that. And 24 minus 8 is 16x. Bring down the next term, minus 20. And what times x gives you 16x? That'd be 16. So 16 times x plus 1 equals 16x plus 16. And just like before, subtract that. And you get negative 36. So we could either write that as a remainder, negative 36, or we could write that as negative 36 over x plus 1. All right, let's look at our next example. All right, again, let's go ahead and do this one. Put the x minus 3 over here. Write out the long polynomial. All right, so we're going to use x squared. Multiply that, you get x cubed minus 3x squared. Go ahead and subtract that. So this is positive, so that's now negative. This is negative, now positive. Okay, first terms cancel out, and 3 minus 2 is x squared. Bring down the next term. And then we're going to use plus x squared minus 3x. Subtract that. So that's now negative, and this one's positive. So negative 11 plus 3 gives you negative 8x. Bring down the next one, which is the 12. And what times x gives you negative 8x? That'd be negative 8. So that's negative 8x. And negative 8 times negative 3 is plus 24. Go ahead and subtract that. Subtracting a negative gives you a positive. This one's negative, which gives you a negative 12 as your remainder, or negative 12 over x minus 3. All right, let's look at our next example. All right, this one is about synthetic division. So this is a faster way to use division, but it only works when our divisor is x minus c. So if it's x plus 1, you can see that as x minus a negative 1. So it kind of looks like that. So c is negative 1 in this case. So for synthetic division, I like to set mine up like this. Then you look at your coefficients. 3, negative 1, 4, and a constant of 10. Also make sure no powers are skipping. So this is power of 3, power of 2, power of 1, constant. So we don't have to worry about any skipped powers. So you're going to write your coefficients: 3, negative 1, 4, negative 10. You're going to drop the first term and put it right there. Then everything after that is multiply and combine. Negative 1 times 3, negative 3. Combine those two together, negative 4. Multiply negative 1 and negative 4, you get 4. Combine those together, you get 8. Negative 1 times 8, negative 8. Combine those together, you get negative 18. So that is what our remainder is. Now, what this becomes when it's divided, well, this was an x to the third here. And so when we divide by x, this becomes an x squared here. So then this is 3x squared minus 4x plus 8, remainder negative 18. Or 3x squared minus 4x plus 8 plus negative 18 over x plus 1. All right, let's look at another example. All right, again, synthetic division. So this is a minus 3 that I'm going to put over here. And I'm going to look at my coefficients: 2, 7, 1, and negative 12. But when I look at my powers, it's 4, 3, 1. So there's right here, there's an understood 0x squared. So when I'm writing my coefficients out, I'm going to put 2, 7, 0, 1, negative 12. Okay, drop your first one, multiply. Negative 3 times 2 is negative 6. Combine those, you get 1. Multiply those, you get negative 3. Combine those, you get -3. -3 and -3 gives you 9. Combine those, you get 10. Multiply those, you get -30. And combine those, you get -42. So then this becomes, started with an x to the fourth, so this is 2x to the third plus x squared minus 3x plus 10 with a remainder of -42. All right, so here's one with x minus 1/2, so c is 1/2 in this case. So we're going to put that 1/2 right here. Look at your powers, 4, 2, constant. So we're missing a 0x to the third, and we're missing a 0x. Very important those aren't skipped when we're doing our synthetic division. So I'm going to put a 2, 0, 3, 0, -1. Drop that 2 down. Half of 2 is 1. 0 and 1 is 1. Half of 1 is 1/2. 3 plus 1/2. Again, you could look at 3 as 6/2. So that's 7/2. Half of 7/2 is 7/4. Combine those, you get 7/4. Half of 7/4 is 7/8. And -1 would be written as -8/8. So -8 plus 7 is a -1/8. So then this becomes 2x to the third plus x squared plus 7/2 x plus 7/4 with a remainder of -1/8. All right, let's look at another example. All right, so here we're asked to find function values. And typically with function values, when we would find f of 1, we would do 1 to the third minus 6 times 1 squared plus 11 times 1 minus 6, which gives us 1 minus 6 plus 11 minus 6, which gives us 0. Now, what's great about the remainder theorem is it tells us that plugging in a value of c is the same as using synthetic division with x minus c. So if we take and we put a 1 here, and we take our power of 3, power of 2, power of 1 constant, and put 1, -6, 11, -6. Drop that down, you get 1. 1 times 1, 1. Combine those, -5. 1 times -5. Combine those, you get 6. 1 times 6, 6. And -6 and 6 gives you 0. As you see, you get 0 either way. So f of 1 equals 0. So we can plug in and get it, or we can use synthetic division as, in my opinion, a faster way to get your function values. So let's go ahead and do that with -2. So you don't have to worry about any exponents or anything like that. With using synthetic division, it's allowing you to plug in. All these coefficients are the same, of course. -6, 11, -6. Drop that down, you get 1. That's -2, and that's -8. -2 and -8 gives you 16. 11 and 16 give you 27. 27 times -2 is -54, which gives you -60. So f of -2 is -60. As opposed to plugging in and worrying about all those negatives, exponents, and everything. Synthetic division does that quickly for you. Let's try it with 3. Again, same coefficients. One, 3 times 1 is 3. That is negative 3. That's negative 9. 11 and negative 9 is 2. That's 6. And that gives us a 0. So f of 3 is equal to 0. So quick and easy way to plug in using synthetic division to find function values. All right, let's look at another example. All right, in here we're going to be talking about factor theorem. Now, factor theorem is just taking the remainder theorem and saying, well, if it equals 0, it is a factor, or even a solution to a equation that's given to you. So we're going to take these three examples here, 2i and negative 2i, so imaginary I, and plug in. Power of 3, power of 2, power of 1, so nothing's skipped. So I'm going to put a 2 here. 1, negative 4, 4, and negative 16. 1, multiply, you get 2. That's negative 2. Multiply, you get negative 4. Combine, you get 0. Multiply, you get 0. And combine, you get negative 16. So we can say that this is not a 0. All right, let's check I. 1, negative 4, 4, and negative 16. 1, multiply, you get I. Now, when I do these, I would definitely want to make sure I like to put it as 0 plus I, so I can keep my imaginaries and my reals separated. So that's negative 4 plus I. Multiply that times that, and a lot of times with a problem like that, I'll typically want to do that somewhere on the side. So I times negative 4 plus I, which would equal negative 4I plus I squared. And remember, I squared equals negative 1, so that's negative 1 minus 4I. And so that's what would go here. Negative 1 minus 4I. Combine those, you get 3 minus 4I. And then, so then you would do I times 3 minus 4I. And that gives you 3I minus 4I squared, which I squared is negative 1, so that's 4 plus 3I. And we get negative 12 plus 3I. So again, this is a no, not a 0, and this is not a 0. All right, let's do the next one, 2I. For 1, negative 4, 4, and negative 16. Drop the first term, you get 1. Multiply that out, you get 2I. So 0 plus 2I. And so that gives me negative 4 plus 2I. So I'm going to multiply 2I times negative 4 plus 2I. And that gives me negative 8I plus 4I squared. So that becomes a negative 4 minus 8I. 4 and negative 4 cancel, so this is now negative 8I. 2I times negative 8I. 2I times negative 8I is negative 16I squared, which becomes positive 16. 16. And negative 16 gives you 0. So 2I is a 0. The other two are not zeros. All right, let's look at another example. All right, so we're going to test to see if -3 and 1/2 are a 0 to this function. X to the third, x squared, x constant, so no variable or skip. We don't have to worry about including extra zeros. So I'm going to put a -3 here. 1, -7 halves, 1, and -3 halves. Bring that down, gives me 1. -3 and 1 give me -3. -3 could be written as -6/2. So -6/2 is kind of what that is. So that would give me -13/2. Multiply that times that. Negative times negative is positive, but that's 13/2 times 3. And so that gives you 39/2. And plus 1, so 1 is 2/2. So that gives you 41/2. And multiply that times that, and we get -123/2. Combine those together and you get -126/2, which half of that would be -63. So not a 0. All right, let's check 1/2. Put 1/2 in right here and do a 1, -7/2, 1, -3/2. Bring down the first number, 1. Multiply by that, you get half. 1 and a -7 give you -6, so this is -3. Half of -3 would be -3/2. 1 could be written as 2/2. 2/2 and -3/2 would give you -1/2. 1/2 of -1/2. 1/2 of -1/2 would be -1/4. And this is putting that over 2, making it now over 4 would be -6/4. So yeah, it gives you -7/4, which this number, as long as it's not 0, you're answering the question and saying no. All right, let's look at another one. All right, for this one, all we're doing is seeing if I is a 0. So 1, -3, and 7. 1, put an I here. So -3 plus I. Multiply by I, and you get distribute that, and you get -3i plus I squared. So -1 minus 3i. And as you see, these are not the same. It gives you 6 minus 3i. And so the answer for this one is also no. All right, that's all the examples I have for you today. Happy studying.